I wonder what the significance of all these digits in this measurement is. Said no one ever. Until today. That's right, we're talking about significant figures. Hit the theme.
Ain't nothing but a chem thing, baby. Two flipped out teachers going crazy. Lancaster is a district that pays me. Unbreakable, so please don't try to break this. But back to the lecture at hand.
Hello and welcome to another episode of SchuFu, Chemin at ya. I'm your host Schu, and with me as always is Fu.
What up, nerds?
You know, Fu, significant figures is one of those concepts that students use throughout the year, whether they like it or not.
True story, bro. So let's get started. Significant figures and the book-ending method, a lesson from the lab skills unit. What are significant figures? All certain digits that we read from our measuring device plus the uncertain digit that we estimate count as significant figures. We usually call them Sig Figs for short.
Sig Figs! Why do we care? Sig Figs tell us about the accuracy of our measuring device, and in turn, our measurement. The greater the number of Sig Figs, the greater the accuracy of the device. We want to preserve this accuracy later on when we use a measurement in a calculation. More on that topic to come.
So later on in the year, when you all are complaining and whining about why do we have to use Sig Figs, we're gonna say accuracy. All right, so how do I determine the total number of Sig Figs? Use the bookending method. Rules. Number one, bookend non-zero digits on the left and right. So put bookends around your digits that are 1 through 9. Ignore the zeros on the outside of those. Zeros to the left of your bookends never count as significant figures. Zeros within the bookends always count as Sig Figs. Zeros to the right, it depends on decimal. Now what we mean by that is if there is a decimal present anywhere in the number, then they do count. If there is no decimal, they don't count. Count the total number of Sig Figs, and that's how many you have. All right, ladies and gentlemen, we're gonna do some examples here. We're gonna go through these 5. We're gonna determine how many significant figures are in each one of these numbers. All right, so follow along. Schu, are you ready?
I'm ready.
All right, let's take a look at number 1. Our rules state to bookend our outside non-zeros. So what is our furthest digit to the left that's not a zero?
It's the 1.
Good, so we're gonna bookend that 1.
Okay.
What is our furthest digit to the right that's not a zero?
It's gotta be 5.
Perfect, all right, so we'll bookend there. And our rules state that any zeros to the left are not significant, so there are none.
No zeros.
Good, what about zeros in between?
No zeros in between.
Okay, and if they were there, remember that they would always be significant. And any zeros to the right, do we have any?
No.
All right, but they would be significant if they were there with a decimal. They would not without the decimal. So how many total significant figures do we have here in example 1?
Well, I'm counting everything right in those bookends, so 4.
4 significant figures, perfect. All right, number 2, let's bookend our non-zeros here. So what's our furthest digit to the left?
Well, some zeros in the front, but 5 would be first non-zero.
Perfect. What is our furthest non-zero to the right?
Well, there is a 0 on the right. I'm gonna ignore that, so it looks like the 1.
Perfect. Now we're gonna do a little shortcut here. I'm gonna put 3 letters above these 3 sections we have.
Okay.
The first section on the left is gonna be N,
N,
and then the middle will be A,
A,
and the right will be DD.
NAD, what does that mean?
All right, good. I'm glad you asked. So this kind of shortens up our rules here. N stands for never,
Never.
so never significant.
So those zeros on the left are never significant.
Exactly. The A stands for always.
Okay, so when we're in the bookends, those always count. I remember that.
Perfect. And the one to the right, what do you think the DD stands for?
Depends on the decimal.
Yes, just like our rule. So a nice quick way to remember this is NADD, or NAD for short. If you put those in, you'll always remember what the rules are, okay? So for this example, how many significant figures do we have?
Well, I know I have at least 3 because of the bookends, but then there's that rule about the 0 on the end depends on decimal. So we do have a decimal, right?
Yes, we do.
So I guess that means that 1 0 on the end does count.
Yes, it does.
All right, so I'm gonna say 4 Sig Figs again.
Perfect. All right, so let's do number 3. Number 3, we have 100. So where is our furthest non-zero to the left?
Well, it's got to be 1.
And the furthest non-zero to the right?
I guess it's 1 again.
It's that same 1, right? So let's put those letters in, N-A-D-D.
Okay, so I know I have at least one sig fig, but it doesn't look like there's any decimal in this number.
There are not any decimals here.
So I guess those zeros to the right don't count anymore.
They do not. No decimal. Those zeros to the right do not count. Good. So how many?
I guess it's got to be 1 sig fig.
It's only 1 sig fig. Yes. All right. Number 4 looks like the same number, right?
Yeah, totally.
All right. It was a little bit different here. So let's do the same rules as before. Let's bookend our non-zeros.
Okay, it's still 1.
Perfect. Put the letters in.
N-A-D-D.
All right, so following our rules, even though this looks an awful lot like number 3, how many significant figures are in this digit?
All right, well, I know I have at least 1 again, but this time there is a decimal. I've never seen a number like 100 point, but there is a decimal there.
Correct.
And so those zeros to the right do have to count, and so that would be a total of 3 sig figs.
Perfect, 3 sig figs. So that decimal, just its presence made those zeros significant. Good. All right, the last one, number 5 here. Let's do the same rules.
All right, so I've got 2 as my non-zero on the left.
Good.
And then I've got my 1 as my non-zero on the right.
Perfect.
Okay, so N-A-D-D. I think I'm getting good at this. I know I have at least 4 in the always.
Okay, so do we see a decimal?
I don't see a decimal anywhere.
Okay, so how many total sig figs in example number 5?
Well, I guess those zeros on the right don't count, so it would only be 4 sig figs.
Perfect. Okay, ladies and gentlemen, now it's your turn. You try part 1. There's 5 examples here. You're gonna go through each one of these, follow the rules, bookend your non-zeros, use your N-A and double D, and please write down how many significant figures each one of these numbers has.
How do I round to the correct number of sig figs? Underline the desired number of sig figs from the left always. Then circle the number next to it, which we're gonna call the next door neighbor. If the circled number, the next door neighbor number, is less than 5, then leave the underlined numbers and drop or zero out the remaining digits. And you'll see more of what that means when we get to the examples. If the circled number is greater than or equal to 5, then round up the underlined numbers and drop or zero out the remaining digits. We're gonna take a look at a few examples. We're gonna round these numbers to the specified number of sig figs. You ready, Fu?
I am.
Here we go.
All right.
In the first example, we're gonna round 127.367 to 4 sig figs. So we're gonna go from the left. I want you to underline the first 4 digits that are significant.
All right, so the first 4 would be the 1, and then the 2, the 7, and the 3 is the 4th significant figure from the left.
Good. Now we want to determine how we are going to round that number. So we want to circle the next door neighbor of that 4th sig fig, which is the 3.
Okay, so the next door neighbor to the 3 is the 6.
Okay, so looking at that 6, is it less than 5 or greater than or equal to 5?
It's greater than or equal to 5.
All right, so what does that tell us to do to the 3?
That's going to round it up to a 4.
All right, so let's write that number with a number rounded up.
I get 127.4.
Notice that we have to drop those extra digits, the 6 and the 7, to make our final number have 4 sig figs.
Okay.
Make sense?
Yes, it does.
All right, let's try another one. We're gonna round 0.0496 to 2 sig figs. Now be careful, we always wanna go from the left in underlining our 2 sig figs, but we've gotta ignore any digits that are zeros because they won't be significant on the left. So what are the first 2 significant digits there?
Okay, so the first significant digit is the 4. We know those zeros aren't significant because they'd have the N over them, right?
Right,
So we want 2 significant figures, so the next one is the 9.
Okay, so we're gonna circle the next door neighbor again.
Okay, that's the 6 here.
And what does the 6 tell us to do?
The 6 tells us to round it up.
Okay, so how are we gonna round up with this number?
Okay, so I have to round a 9 up, which rounds up to a 10, but that has to be a 0 to then carry the 1 over to the 4 to make it a 5.
All right, sounds good.
So I'm gonna write 0.0, and those weren't significant.
Right.
5?
Well, you're actually going to think of this as rounding 49 up to 50. We're going to need that extra zero.
So 0.050, because that zero would be significant because there's a decimal in the number.
Exactly, very good. So that's how we get 2 sig figs in the end.
Perfect, okay.
Nice job.
I'm getting this.
Good. All right, so number 3, we're gonna round 121,134 to 3 sig figs. So again, from the left, underline 3 sig figs.
All right, so the 1, the 2, and the 1.
All right.
And the neighbor is that 1 in the 100 spot.
Good, now what does that number tell us to do?
All right, so that's not gonna do anything. That doesn't round up. That is below 5, so that's gonna...
Yeah, we're gonna keep it the same. Make sure you never round down.
Perfect.
All right, so what would you write then?
All right, so 121, and I'd put the zeros in, right? Because they wouldn't be significant because there's no decimal. But 121 wouldn't make sense. So
No,
it's got to be
it wouldn't.
121,000 because you wouldn't round 121,134 to 121.
And students do that, as a matter of fact, but you caught on right there. So what you're noticing is with 1 and 2, we are sort of just dropping out the decimals, but with big numbers like 121,000, we're gonna zero out those extra digits just to maintain the number place.
Okay, good.
Nice job.
Thank you.
You try part 2. You're gonna do something very similar to what we just did. You're gonna round the given numbers to the specified number of sig figs. Make sure that you show some work with underlining and circling. That does it for today's episode on significant figures.
Later, nerds.
Today's episode is brought to you by
More cowbell.
Guess what? I got a fever. And the only prescription is more cowbell.
But we never off, always on till the break of dawn. SCIENCE in the hall they call S-Wing. You know we never wear a tie like my homies, boys to men. It's so hard to say goodbye.
Like this, that, and this, and it's like that, and like this, and like that, and it's like this.
You're going in low power mode.
Plug and chill to the next episode.